Welcome viewers to Bodhi Unified Flow. Here we simplify complexity and amplify performance. Today we're diving deep into value stream mapping, or VSM, finding inefficiencies in project life cycles. VSM Metrics and Measurements, the math behind the map. It's an incredibly powerful topic, so let's jump right in.
Here's our agenda for today's explainer. We'll start by exposing those hidden inefficiencies that plague so many projects. Then we'll define what value stream mapping actually is. From there, we'll unpack the exact mathematical metrics that optimize your workflows, look at how to implement this directly in real-world construction, and wrap up with a quick summary and our references.
By the end of this session, you're going to have a really concrete understanding of VSM as a diagnostic tool. You'll master the 5-stage implementation process, and most importantly, you'll know exactly how to calculate the core mathematical indicators. Mastering cycle time, lead time, and the value-added ratio is absolutely crucial, and applying Little's Law will empower you to drastically improve your project delivery.
Section 1. The Hidden Inefficiencies. Recognizing downtime in projects. Okay, we really need to start by looking at where our time actually goes in traditional project management. And honestly, it's pretty shocking. The data is crystal clear. In many traditional processes, actual value-added work accounts for less than 5% of the total lead time. Let that sink in for a second. Less than 5%. That means a staggering 95% of your project lifecycle is consumed entirely by non-value-added time, or waste. This massive chunk of lost time is mostly waiting for approvals, moving materials around unnecessarily, and all those hidden delays we just kind of accept as the way things are done.
To fix this, we have to clearly draw a line between our activities. On one side, you have your value-adding activities. This is the actual processing, the physical transformation of materials, the critical problem-solving. On the other side, we have non-value-adding activities. In lean philosophy, this is known as muda, which literally means waste. Imagine a crucial design document just sitting on a desk for 3 days, waiting for a single signature. That right there, that's muda. It includes all those waiting times, excessive handling, costly rework loops, and approval lags that silently drag our projects down without us even noticing.
Section 2. What is value stream mapping? Visualizing the flow of value.
So the million-dollar question is, how do we find and eliminate this massive 95% chunk of waste? Well, we use a tool called value stream mapping. VSM is this incredibly high-level strategic tool that brings together both material and information flows. By using standardized icons, it visually maps your entire process from product inception all the way to final delivery. Think of it like a highly detailed X-ray of your entire operation. It allows your team to see exactly where the product stops, where it flows, and it brilliantly exposes those hidden bottlenecks that normally go completely unnoticed.
Now, to actually execute this, we rely on a highly structured 5-stage process created by lean pioneers Rother and Shook. First, you select a specific product family to focus on. Don't try to boil the ocean. Second, you meticulously create a current state map, documenting things exactly as they are right now, warts and all. Third, you identify the wastes and design a streamlined future state map. Fourth, you propose a concrete, actionable plan to bridge the gap between the current and future state. And fifth, you implement that plan. It's a systematic journey to an optimized reality.
Section 3. The math behind the map. Quantifying performance with VSM metrics.
Let's move to the real core of our explainer. This map acts as your decoder ring for true process efficiency. We have 3 fundamental mathematical indicators working together: cycle time, lead time, and the value-added ratio. While the map gives us the visual flow, these metrics allow us to accurately quantify exactly where our time is bleeding out. After all, you can't fix what you can't measure. Let's break these equations down.
First up is cycle time, or C/T. This is strictly the time that passes from the very beginning to the end of an individual activity. It is the actual active processing time. So if it takes a worker exactly 2 hours to assemble a specific component, those 2 hours are your cycle time. Simple enough, right? When we take the summation of all these individual cycle times across a value stream, we get our total cycle time. This represents the true active effort required to complete the work with 0 interruptions.
Next, we have lead time, and this one is absolutely critical. Lead time is the total cycle time plus the total waiting time. It represents the entire duration from the moment a process starts until the final delivery to the end user. Lead time is almost always significantly longer than cycle time because it accounts for all the delays, the handoffs, and the inventory just sitting idle. If that 2-hour assembly task from our last example sat in a queue for 5 days before someone actually picked it up, your cycle time is still just 2 hours, but your lead time is over 5 days. That's a massive difference.
Which brings us to the ultimate metric, the added value ratio. The formula here is simple but incredibly revealing. You take your total value added time, divide it by your total lead time, and multiply by 100 to get a percentage. Going back to our example, if you divide a tiny cycle time of 2 hours by a massive lead time of over 5 days, you get a brutally honest percentage. Calculating this ratio often confronts teams with that harsh reality, that staggering 5% efficiency figure we discussed earlier. It is definitive mathematical proof of how much schedule is lost entirely to non-value-adding activities.
And then there's Little's Law, a fundamental mathematical certainty in lean management. Little's Law states that work in process, or WIP, equals throughput multiplied by lead time. What this means in real practical terms is that if you want to reduce your overall lead time, you can't just yell at people to work faster. You have to put a strict cap on your work in process. Think of it exactly like a highway. If you pack way too many cars onto the road, which is a high WIP, massive traffic jams occur and everyone's travel time goes way up. Fewer items in the system simultaneously means every single item flows through much faster.
Section 4. Implementing VSM in construction, real-world impact and case studies.
So the theory is totally sound, but how does this hold up in reality? In the highly complex, messy environment of construction, VSM serves as a critical bridge between your high-level strategic plan and actual tactical execution on the ground. On-site practitioners use these value stream maps to visualize the day-to-day workflow. By mapping out exactly how information and materials are flowing, they can pinpoint bottlenecks and implement targeted interventions. This directly reduces costly, disruptive rework where it matters most. The mathematical results in the field are just undeniable. Take a look at this. In a 2019 study by Ginduz and Nasser, applying VSM to an underground pipeline project achieved an incredible 30.7% reduction in lead time. Let me repeat that, a 30.7% reduction just by visualizing and optimizing the flow. By eliminating waste and focusing heavily on value-adding activities, they also managed to decrease overall project costs by nearly 21%. That is a real game changer.
And we see similar immense benefits across all different types of builds. In architectural residential building projects, researchers documented up to a 34% reduction in overall project duration. Simultaneously, they saw a 22% increase in actual value-adding time. How? Because VSM actively removes the waiting and transport wastes. That directly shrinks the lead time variable in our math equations, naturally leading to highly streamlined processes and vastly improved resource utilization.
Section 5. Summary and References. Achieving the Bodhi Unified Flow.
Let's summarize the key takeaways we've covered today. We've seen how VSM functions as a diagnostic X-ray, exposing that 95% of non-value-added waste hidden in standard workflows. We walked through the 5-stage process, guiding us from a flawed current state to an optimized future state. Most crucially, we unpacked the mathematical engine of VSM, quantifying inefficiency through cycle time, lead time, and the added value ratio. And of course, we learned how Little's Law allows you to definitively control your work in process to slash those lead times.
The math is absolute, and the map is clear. When you use these tools, the invisible barriers to your project's success become completely visible and entirely solvable. So the only question left for you as a practitioner is this: how quickly will you apply these metrics to amplify performance and eliminate the hidden waste in your own project life cycles?
For those of you who want to study the math and methodology even further, here are the key academic papers and industry standards cited in today's explainer. This includes the foundational works of Rother and Shook, the pipeline case studies by Ginduz and Nasser, and the IS-1 5883-1 Construction Management Guidelines. Thank you for joining us at Bodhi Unified Flow, where we simplify complexity and amplify performance.